Physics students, as we start with graphs. So I want you to understand how to read graphs today and how to analyze it really well. So there are three things you do with a graph. The first thing you do with a graph is just read it directly. Look at the y-axis, get a value for it. The second thing you could definitely do is just take the slope. And the third thing you do is to find the area underneath the line or the curve. And usually you measure it from the x-axis. So take a look at this graph with me, if you don't mind. There we're going to have force, which is the kilogram meters per second squared, and a distance, x in meters. So here's a line. How would we get a mass times velocity squared as an equation from the different things you do with the graph? Now, mass velocity squared is a kilogram meters squared per second squared, which is a mass length squared over time squared. Notice we're using dimensionality. So if you read it directly, you get kilogram meters per second squared, or force. That's not the same as meters per velocity squared. So that does not work for our units. Next up, we can take the slope. Kilogram meters per second squared divided by meters. It's kilogram meters. You can see right here. You end up with just mass over time squared, which is not what we want. Now, if you do the area, which is multiplication, you get force times x. And by doing it, you end up with, you can see here my units, kilogram meters squared over second squared, which is what we want. It's a mass length squared over time squared. So we just said that if you find the area from a force and distance graph, you get mv squared, which some of you may realize from 1/2 mv squared gets you energy. Again, that's if you already had physics or some kind of like calculus training. So when it comes to position graphs, which is position versus time there are a couple things we could do. I just drew a random curve here. First off, if you measure it directly, you get meters. Fantastic. If you take the area, you get meters times seconds, which really is nothing in physics. If you take the slope, you get meters over seconds, which is the velocity. So with position, velocity is kind of like the most important thing you can take from it. Now let's take a look at all three kind of graphs. So position graph, you just told me the slope is your velocity. For velocity graph, if you just read it directly, you get the velocity. If you take the slope, which is velocity over time, that's the acceleration. If you take the area, which is velocity times time, you end up with meters per second times seconds, which is meters, which is position or displacement. For acceleration, direct measurement is A. Slope is acceleration over time, is a jerk. We don't know that. And just reading the area gets you velocity. So you can see right here, for example, position. If you've got like that purple line, that's a change in linear displacement, so which means a constant velocity, no acceleration, because you're having the same approach. The green line is no change in position, you're staying still, which means no velocity, no acceleration. And finally, that kind of curved line, the change in position is a quadratic function. You can't see it, but the velocity is changing, so the acceleration is there. Next up, let's look at velocity. There's a curved velocity graph. A curved velocity graph means that there's a changing acceleration. That's not usually the case you see in physics, but here's what I care about. That area we see there's a negative displacement. That other purple area is a positive displacement. That point right in the middle there, is that the point where the net displacement is 0? And the answer is, of course, no way, Jose. Because at that time, you'd have only negative area underneath the slope. The net displacement is 0 at the time in which those two areas are equal, and that hasn't actually happened yet. So for the third kind of graph, let's talk about looking at graphs in our summary. The first thing I want you to do is look at the axis. Units are super important. Also, curves versus linear. Curved displacement means you have an acceleration. Curved velocity means you have a change in acceleration.